Hello, this is MATH1131 Calculus, and I'm just doing a selection of problems on the calculus course. This one's from Chapter 2, Question 1e. So it's one of these limits to infinity examples here, and I've got one function divided by another function, and we want to look at what's happening to this as x gets very, very large. As x gets very large. I like to sort of do these firstly heuristically, that is, I just think about the size of things, and then I'll do it more formally using algebra. So when I look at these two expressions here, you sort of think of x as being a very large number. If you like, you can think of it in terms of money. If x is $1 million, then where's the money? Well, in the numerator, that's going to give you, that's where the money is in the numerator. 5 times a million squared is very, very large, much bigger than just 3 times a million. And the cos, well, the cos can't ever be bigger than 1. It's bounded between 1 and minus 1. So on the top, that's what I call the dominant term. That's where the money is on the top line. If x is very large, well, 4 is not very big. That can't be bigger than 1. That's where the money is in the bottom, the x squared. If x is $1 million, then you go for the x squared. So for x large, the dominant term on the top is 5x squared. Dominant term on the bottom is x squared. Forget the rest for the moment. This is roughly 5x squared over x squared, which is 5. So heuristically, we're expecting to get the answer 5 out. Now, you can't just write equals 5 because you haven't given any really proper mathematical reasons, apart from just looking at it and using your common sense. So what I'm going to do is, our basic rule when dealing with these sorts of expressions is you divide by the highest power of x in the denominator. You divide by the highest power of x in the denominator. And there it is. There's the highest power of x in the denominator is the x squared. So I'm going to divide top and bottom by x squared, and that usually does the trick. So I divide top and bottom by x squared, I get 5 minus 3 on x plus cos 7x divided by x squared, all divided by 4 over x squared plus sine 2x divided by x squared plus 1. And now you let x become very big. And as x becomes very big, well, 5, nothing happens to 5, it just stays the same. 3 over x is going to go to 0. Cos 7x over x squared, well, cos can't be any bigger than 1, so that's going to be 1 over a very big number, which is going to 0. This is going to 0. Sine can't be bigger than 1, that's going to 0, and I just get 1 in the denominator, and that's 5, which is what we thought was the answer heuristically. Now, just to make sure, sometimes you may have a slightly fussy tutor who wants just a little bit more information here, and you might write down here, since cos 7x and sine 2x are bounded by 1. So that would mean that cos 7x over x squared has to be less or equal to 1 over x squared, and on the other hand, they're bigger than minus 1 on x squared. So cos 7x over x squared goes to 0 by the pinching theorem, which comes a little later in the course, by the pinching theorem. And similarly, for sine 2x over x squared. In an exam, you could probably get away with simply saying that these are bounded by 1, and so the limit is 0 without being quite so formal. But when doing this, that ought to be sufficient to write that down. And that's the end of the problem.